Assalamu alaikum. Welcome to Module 3 of Practical Numerical Methods for Scientists and Engineers. This module is related to roots of single equation. So, if you have single equation and you want to find the root of this single equation, so we'll start with a graphical method, and here it's a simple method for estimating the root of fx equal 0 by plotting the function and observing where it crosses the x. So where it crosses the x, it will be the root as we said before. Okay, so Excel can be used to find as following. So first step, begin with two guesses that bracketing the real roots, and then check when fx become positive and the next fx directly become negative. So once you have fx positive and the next one become negative, that's mean so it cut here, it cut between the two x's. Okay, now you can take this new x's, as a new guesses. Okay, and then repeat these steps again. Okay, until you get a satisfied results. Okay, so let's try it by Excel now. So let's take this example. We want to apply this equation. Okay, so this is graphical approach to determine the drag coefficient needed for parachutes of mass, this mass kilogram, to have a velocity of 40 after free falling for time seconds. So we have a time is determined by 10, and the mass is already indicated by 68.1, and C, I don't know the C, he want to determine the C, and G is of course it's the acceleration gravity, and it's 9.81. So we want to the example gave me 4 and 20 as the initial guesses. So how to perform it? First, now I have 4 and have 20, so you can make many points as you can between 4 and 20. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then for the function here, okay, here we should make like a constant. Okay, so constant G, 9.81 mass and time and velocity. Okay, then here for f of c or f of x, we can create the equation based on c. So just we want this equation, create the equation based on this fixed parameter. Remember that when we want to create fixed one, choose the fixed one, you have to press F4 in keyboard. So F4 in keyboard will fix this cell. So instead of p, for example, this p2, p2 1 2 3 4, instead of p4 it will be converted of p, not this one, sorry, I mean this one, so g. So this will be fixed. So instead of g or e1, so instead of e1, when you press F4 it will be E dollar sign 1 dollar sign. Okay, so that's mean when you go down or drag down the by your mouse, when you drag down, so it will be fixed, it will need to go, so only that one you choose will be calculated here. So each time, for example, c here is not fixed, so c is variable, but the other parameters are fixed. So every time when you go down, he will take the c from the new cell, but it keeps the constant from the old cell. I think this is clear. Okay, okay, so once you plot all of them, so now of course this is my plot. Okay, now check where is the positive and where is the negative. So all of them are positive until 14 15. From 14 to 15 they become negative. That means my true roots is my true roots lays between these two limits, 14 and 15. So I can start my new, our second trial between these two between these two trials, the two limits, and I can here calculate the tolerance in function. So tolerance in function fx through minus f numerical solution. So it will be 0 minus 14. So here I can take the average. X average is upper plus minus upper. Okay, is sorry, the x is 14 plus 15 over 2, and then the related function will be 0.5. So it will be the fx will be between it's still far away from the real one. So okay, now we'll start a second trial. So start a second trial based on 14 and 15. So now we'll start by 14 and 15, and you can take as many points as you can between them, and then apply the equation again. So here you can see all of them are positive until you from 14.8 until 14.9 become negative. Okay, now we calculate the average of them. X become 14.9 plus 14.8 plus 14.9 over 2, so p 409. Then the equation of this one will be 0.09. So now the new solution become the x become fx become very close to the root. Okay, third trial. Okay, remember we repeat the same. Okay, so now I start from 14.8 and until 14 point, we showed 14.9, but interestingly just when I go for 14.81 it converted to negative. So this is my trial, and here I have numerical tolerance in function become 0.012. The previous one was 0.9 and the previous one. So as I'm going further trials, I'm going to more close to the real solution. So this is all about graphical methods. Hope you enjoyed, and see you in next session.